Okay, so for the first question, it asks there are five small parts. So for the first one, it asks for a valid A, so the joint density function is valid. So we know that the integral of fxy should be equals to 1, and we can write the integral from -1 to 1, from -1 to 1 of 1 plus xy over a dx dy should equals to 0. So we just need to solve this equation to get a. So first we can take the 1 over a out and then solve for this part. So we get that 2 times 2 over a equals to 4 over a should be 1. So we can get a equals to 4. And so for the second question, it asks for if xy are uncorrelated. So in order to determine if they are correlated or not, we just need to see if expected value of xy equals to expected value of x times expected value of y. So in this case, because we find a in part 1, so we can plug in 4 here to get the density function of fxy. So for first, we calculate expected value of xy, which is the integral from -1 to 1 and -1 to 1 of xy times 1 plus xy over a dx dy. And by solving this equation, we get expected value of xy should equals to 1 over 9. And then we find expected value of x, which is x times the density function from -1 to 1 and -1 to 1, 1 plus xy over 4. Which is there should be an x here. I forgot to write it here. So it should equals to 0. So from now we know that no matter what expected value of y is, the value of expected expected value of x times expected value of y should equals to 0. However, from this part, we see that the expected value of xy is not 0, so they are correlated. So for part 3, it asks if they are independent. In order to determine if a two variables are independent or not, we need to see if they are correlated and if they are normal. So in this question, they are not independent. And for part 4, it asks for find the density function of x squared and y squared joint density function. So we can see we write z as x squared and w equals to y squared, and the Jacobi like this. And so we plug into the formula to get zw in this way. And it should, after simplify, we get 1 over 4 times z, the square root of z times the square root of w as the density function of fzw. So the next part asks for proof or disprove x squared and y squared are independent. So to see if they are independent or not, we first calculate x squared times expected value of x squared times y squared, which is equals to 1 over 9. And then we calculate x squared, which is just use x squared times the density function, and we get 1/3. And then for calculating the expected value of y squared, we get 1/3 as well. So the difference between expected value of x squared times 1 squared y squared minus expected value of x squared times expected value of y squared equals to 0. So they are independent in this. That's it.